Okay, so we will continue. We will do problems on chapter 7 and 8, the problems I sent you. Do you see now the PowerPoint of problems?
Yes.
Yes, yes.
Okay, so for the first problem, it's an application of solar thermal energy. Uh, I want just to tell you that some basic concepts that you have, I will not include the chapter 2 and 3 in the exam, but for the basic concepts, you should know them. You should know, for example, that sensible heat is m dot Cp delta T. These are basic equations to be able to solve for applications of solar thermal energy. Okay, so a solar collector of efficiency 80% and area of 20 meters square receives 500 watt per meter square of incident solar energy per unit area. Knowing that the temperature of water entering the collector,
Doctor,
yes, yes,
can you let in, please?
yes.
Thank you.
But yeah, we only need to know the basic. No, we only
Yes.
need to review basic.
No need to review the complex issues. Just the main formulas. Convection is HA delta T. Convection, let's say, sensible heat is m dot Cp delta T. And if I give applications they will be simple as this problem, not complex issues, but just you should know the concept to be able to solve the problems.
Okay. Yes.
Do you see the screen?
No, we are not.
Yeah, I will share it again. Let me share. Okay. So here,
Doctor,
yes.
in chapter 6, do we have the Bernoulli equation and its derivation?
No, you don't have the derivation, but you should know how to apply it.
Only the Haida, the Bernoulli.
Yes, exactly.
The general equation.
Yes.
All right.
Okay. So.
And also there is a relation between velocity cubed and the power and something. Do we have to use it also?
You don't need, look, you have at the end it's open book. You can write the main formulas on a paper. You don't have to remember anything, but you should know how to apply them. Okay. So you can write all formulas on one formula sheet, and just I want you to know how to, what is the meaning of each parameter. So if you have a simple problem, you can solve it.
So we'll have solving problems from chapters 6, 7, and 8, right?
Mainly, yes, mainly أكتر شيء 7 and 8, and if we have from 6, and it will be just applications of the formulas, not complex issues. You should understand the formulas of chapters, for example, of wind and energy or hydropower. Okay, you have for hydropower you have mainly the Bernoulli equation, which will tell you how energy is converted from one form to the other. So this one you should know it, and you should know how to apply it. You should understand this formula. And for wind and energy also, you should know the formula of power. This will give you the power that can be extracted from the turbine. That's it. No, not more than this. The derivation, no, I just explained them for you because, especially for mechanical engineer, it might be of interest. Okay, but you don't have to derive anything, and you need to understand the final formula and how it will apply. Okay.
Miss, I have a question regarding the information مثلا ممكن نسأل عليها بالمالتيبل choice. There's a lot of informations interesting in the slides, بس كيف بدنا نسأل عليهم مثلا what do you expect us to kind of remember from slides?
It's similar to the style of the first exam. They will test concepts. For example, they can tell you which of the following statement is true. Let's say wind energy is the most used renewable energy, for example. No, the most used one is solar energy. So such things.
Okay.
So if you read 2-3 times the slides, يعني no need to just يعني know them by heart, but if you read them several times, you will have the ideas clear in your mind.
Okay, thank you.
Okay. So here we have a solar system, and the solar collector has an efficiency of 80%. When we give the efficiency of the solar collector, this means that what is the percentage of energy used from the energy absorbed? Okay, this is the efficiency. So the efficiency is the percentage of useful energy compared to the total energy absorbed. And we have that this solar, we have for this solar collector a flux of water that will enter and exit. Okay, they said that the inlet temperature is 293 Kelvin. The exit temperature is 333 Kelvin. So we know initial and final temperature. We have the area of the solar collector A is equal to 20 meters square, and the solar energy received by meter square is 500 watt. Okay, so this is the solar incident energy. It's equal to 500 watt per meter square. So first, from the properties given for the solar collector, I can calculate the useful energy. Okay, so useful energy will be equal to what? Useful energy is the efficiency. يعني such formulas يعني you should يعني it's basics يعني you should know that. Okay, so what is the energy absorbed? The energy absorbed is, so you should take into account the energy absorbed times the efficiency, because not all absorbed energy will be used. We will have losses. This is why they gave us the efficiency of the solar collector. So it's energy absorbed times efficiency.